So we're gonna find out or review what all this stuff is for. Why do we care about intercepts? What they mean? When we start talking about real life problems like making money and draining jacuzzis and all that stuff, their intercepts actually mean something significant. Usually, the start or the end of something, or where you have $0 or you haven't worked yet, zero time. So put all this stuff in context and have it actually mean something. So the first two, I think we give you the words, like the explanation of the scenario, and you have to come up with the graph and the functions, like what the equations are. That's the first two. And then the next two, we give you the functions, like what the actual slope, y-intercept is, if there is one. But then you, from here, go ahead and graph it, and then describe in words what does this mean. So you have to come up with the words and the explanation of the scenario. And they give you a little bit of it like they're driving, so you have to put together, well, if you're driving, what does 45 stand for if you're driving as a slope? What does 60 stand for as a slope if you're driving? And then that's here as well on this one. And the last two, we give you the graph. And then from the graph, you have to say what the function is and then what the earnings are. Come up with a word. So there's 3 different things that are going on here, and there's 6 problems. Every 2 problems has one thing given to you, and you figure out what the other 2 are. Alright. So let's start here. I'll set up, get you started, remind you of some good techniques we used. But the most important thing is not to just make things up and just say, well, I see a 4 and an 8, so that means this is the slope and this is the y-intercept, and you're just randomly making things up. Okay? It's easier if you make sense out of it. So a good strategy is to make a chart. So we have two people. Make a chart for each. Make a chart for Zane. And we got hours worked and money made, so you can use hours and dollars. And just list how much does Zane have after he's worked so many hours. It says here he works 4 hours total, so we're assuming from here $8 an hour he gets paid. So we have $1, $2, $3, and $4 for our hours worked. And if he's making $8 an hour, how much money does he get after the first hour? Yeah, just $8, right? Make it bigger. Just $8. How much money does he have after 2 hours? Yeah, and 3, and 4. And now you have some easy points to graph. So if you can't read this and just go ahead and just graph it easily, which most probably can't, make a table. Even though it doesn't say make a table in there, you have to use these tools as you need them. And then you can say, well, I know how to graph 1, 8 and 2, 16. That part, okay, I know how to do that. And the idea here that 1 hour you get $8 and 2 hours you get $16, I knew that too. But just putting it all on the table makes it easier to transfer over to a graph. And then just do the same thing here for Baylor. Baylor, it's the same almost, but making $10. So still hours and dollars. So still works 4 hours only. So after 1 hour, Baylor has $10. 2 hours he has made 20. After 3 hours he's made 30, and after 4 hours he's made $40. And by the way, for both of these, if you don't work, how much do you make? 0. Yeah. So that's that additional information. They don't tell you that. They just say you work 4 hours, but you have to assume, like, well, yeah, just by common sense, if you don't go to work, you don't get paid. Now you'll notice here, they're not numbered for you. So you have to come up with a good numbering system that works. A good numbering system means you use the whole graph. Right, so something you would not want to do is this. Well, the H's or the X is 0 through 4. So you do this. 0, 1, 2, 3, 4. You wouldn't want to do this because it would only use this part of the graph here. You wouldn't be using any of this over here. So if you know the highest you're going to count to is up to 4, space it out a little bit. 1, 2, 3, 4. So we're using pretty much the whole graph. So this is just looking at your domain, saying it only goes up to 4, and spacing those 4 all the way out the whole axis. And do the same thing with the range. What's the highest number of the range? 40. So you want 40 to be up here somewhere, right? You don't want to count by 5s and you want to get to 40, right? You need to count by something so you end up at 40, so you're able to graph everything. So what would be a good value to count by? 8, 10. Yeah, there's different ways of doing it. And I would do 10 every other, so technically we're counting by 5s. I'm just labeling every 10. So 5, 10, 15, 20, 25. But I know 40 is the highest that I have to graph, so I want that to be the highest number on my range, on my y-axis. Now go through and graph. Okay, Zane, 1,8, I'll have to estimate. So here's 1 hour, he's made $8, a little bit before 10. And after 2 hours, he's made $16. So this is 15. 16 is a little bit above that. 3 hours, made 24. 4 hours, we've made 32. And there you have it. Use your straight edge. And technically, since he says he only works 4 hours, this graph stops at 4 hours. It doesn't keep on going like some of the ones we did yesterday. Word problems usually have some defined domain. They're only from this amount of time, from 0 to 4 hours, and that's it. And then do the same thing for Baylor. Now, do you anticipate Baylor's graph to be above or below? Why? Okay. So Baylor makes more money. The slope is bigger, so we anticipate the graph to be above. So we're trying to tie all these meanings all together. Making more money is a higher slope, which means it goes above. So just by looking at this graph, I can tell who made more money and approximately how much more money. Let's see here. What's the function of the graph? What's the equation of the graph? And you have a lot of tools for doing this. You could go through and do y equals mx plus b like you did on yesterday's and on the quiz. You could plug in m, like count the dots, or you could take 2 points and calculate the slope that way. Okay. Lots of different ways of doing this. The y-intercept we already can see, and we already know the y-intercept is 0 for both of them. Okay. So what is the slope for Zane? And what is the slope for Baylor? The y's go up by 8. The x's go up by 1. 8 over 1, or just 8x. Which, of course, coincides with $8 an hour. So remember, this is money right here, so he's making $8 for every hour. $8 an hour, 8x. $10 an hour for every hour, 10x. So the slope is not just some random number that has no meaning. When we're talking about real life, it's how much somebody's making or how fast a car is moving. All different types of applications. Okay. Domain, just go ahead and list what the domain and the range is. Okay, you guys know how to do that. And compare. This is where you compare two graphs. You can say something like Zane makes less money per hour than Baylor, or Baylor makes more money per hour since the line's steeper, or Zane's line is less steep, so that means he makes less money. Go ahead and use that same language we have been using as far as the steepness of the line. So really, when we're talking about comparing, there's a lot of things to compare, but steepness is probably one of the most important ones. Steepness of the slope, steepness of the line. Equate somebody making more money with the graph of their money made being steeper. Okay. And now it's a matter of, well, what if I give you, on the third one, last one on that side, what if I give you the function? So what if I just give you this? Can you come up with the graph? And then could you write one of these? From given the function, could you write this? If I gave you Zane's function is 8x, could you come up with, okay, Zane worked for 4 hours, he earned $8 an hour. Could you translate this 8 here, okay, to an actual meaning of $8 per hour that he's making? And that's what your goal is. Okay. So 45, 60. Jonathan drives a Mustang as modeled by f of x. Okay, so he's traveling. How fast is he traveling? Yeah, so he travels, and that's when you'd write out 45 miles per hour. And similar for the Camaro. Now, if you're going to graph this, what do we need to count by here? So if you graph by 10, let's say we did 10, 20, 30, 40, 50, 60, and this Camaro is going like 60 miles per hour, it looks like. Well, after 1 hour, it's going to be 60, and then after 2 hours, it's already off the graph. So you can barely graph it if you only count by 10. So choosing the right number does make a difference. Counting by tens is not good. You won't use the whole graph. So you have to play with these numbers and maybe make some charts if you have to. Say 45, 60, add another 45, you get 90. Add another 60, you get 120. Add another 45, you get 135. Add another 60, you get 180. Okay. So in order to graph just 4 hours, you need to be able to go up to 240 miles. So again, table does help you determine, well, how should I be counting on my y and x axes. All right. First one on the back is the same, and the middle one on the back. Now we give you the equations. What can you tell about the equations right here just by looking at the graph? What can you tell about these two? You might be able to just pick 2 points, do the rise over run, get the equation. Pick 2 points, do the rise over run, and you can go ahead and get the equation. So that's how we got the equation a long time ago. That was the first box on the review yesterday, getting the equation from a graph as opposed to using the skeleton and using the slope-intercept form. And then from this, we know it's money, earns, because we're talking about money and hours, so you can use like the first one to help you out. After 3 hours, Frankie made how much money? After 4 hours, George made how much money? You can read the graph and come up with, well, once you get the function, what all this stuff means. Okay. I'm going to let you work the rest of the period to get these done. We'll go over a few of these tomorrow, but I urge you, just like today, I'm collecting them pretty fast. Don't be that person that comes in with half blank and then you're really fast trying to finish it. It's not going to help you on a quiz or learn anything. You have to spend time with this outside of class. Okay?